Hello, Java programmers. Let's introduce object-oriented programming, a topic that you will see and experience and work with probably for most of your career. First, I want to discuss a little history, then some motivation, why we do what we do, and then get into the details of OOP. Before we had OOP, before we knew about object-oriented programming as mainstream developers, we always had code and data. So we wrote functions, which are the same as methods at this point. You know what methods are. And we created a lot of data structures, arrays, complex data structures consisting of, many strings and ints and floats and doubles all lumped together, because everything in the real world is more than just a simple data type. I mean, there is no string that describes something in the real world. It may describe a characteristic of something, but if I want to model even the simplest thing, like a person or perhaps something even simpler, a book, that something is going to have many, many characteristics. And I find myself using built-in data types like integers and floats and strings and booleans in combination to represent that thing in the real world. And we refer to that set of data, that construct, as a data structure. And I refer you to this book that I've talked about many times. I think we might be able to get some more space on the screen. There we go. And I link to this book at the end of the presentation if you need it, but it was written to overview for the purposes of describing programming. Here's how we do what we do and why we do what we do, independent of OOP and also independent of any particular language. And that makes it a really good book for developers to have, to think about the big picture and what it means to use an array, what that happens in the background when we do that. So if you're interested in being the best you can be, I recommend spending a couple dollars and devouring a copy of this book. It's certainly not required for the course. We had a problem. If you imagine a very large project with thousands and thousands of lines of code, maybe hundreds of thousands of lines of code, and throughout that project we had data structures, and we were effectively modeling things: temperature sensors, motors, people, student records, cars, boats, planes, trains, automobiles, whatever was necessary. And we could build these models, and we understood how to do that using all of the native data types. But as the projects got more complex, we found ourselves with an issue. If you jump into a project, maybe you've been away from it for a while, or maybe you're looking at an aspect of it you haven't seen before, and you need to perform some operation on that data structure. Oftentimes you didn't know what the functions were that would perform that operation for you because they were so disconnected logically from the data structure. The code was there and it worked, but finding it was problematic. And you may have to go ask a colleague or do a lot of research throughout the code base to find out, how do you initialize this book object, or how do you destroy this motor object. And we made mistakes because of that. We just either found ourselves rewriting code that we already had, or using the wrong algorithm, the wrong code to manipulate that data structure. And that just ballooned over time and the code got worse and worse. Well, some computer scientists and philosophers and psychiatrists perhaps came up with the idea that as human beings, we look around us and we see objects. And I say that I'm holding a book in my hand, and everybody knows what a book is. We could consider that a class, perhaps. So intuitively, when I tell you I have a book, you begin to understand the things that can be done to that book. You can open it, read it, burn it, throw it away, sell it, buy it, write in it, and you've mentally bound or connected particular algorithms to that class, to that book class. And computer scientists thought that maybe we should create programming languages that let us do the same thing, that let us create classes and then instantiate those classes to be individual objects in our program. And you can decide whether this is right or wrong in your situation. As you go through your work, just keep in mind that's the way that this paradigm, object-oriented programming, is supposed to let you operate. It's supposed to let you work the way that you theoretically see the world. And it's pretty reasonable. I mean, it's not perfect. We certainly don't want to think of the people around us as strictly objects. But when it comes down to writing a program, it's kind of accurate, I believe. Along with OOP came a whole boatload of new terminology. And one of the things that struck me, because when I was a baby programmer, we didn't have OOP, or we didn't use it anyway. And when we finally did begin adopting it at the different places I was working, one of the things that struck me was the amount of terminology. It's very important that we all speak the same language of tech. Therefore, it's important that when I use these words, you are able to understand them and apply them in your work. If I tell you to create a class, then you'll know what to do in Java. If I tell you to instantiate an object, you can rest assured that you will hear that same phrase but from your peers at work. So instantiating objects, designing and implementing classes, those are things that everybody says to each other in the OOP world. I'm going to go over all of these as they become relevant. We'll talk about the importance of data hiding, talk about how to implement inheritance, but instead of just defining all of them for you right now, we'll wait until they become relevant and we'll talk about them using examples. The first term that we're going to look at is class, and we will use as our definition a class is a software construct that models something, meaning it's not a variable, rather it's a template for creating variables. And once you've built that template in Java or any other OOP language, you can use that template to create objects, and that process is called instantiation. And just to repeat that and put it all together, we implement a class from a design, and then we instantiate objects from that class. You'll see me do that over and over and over. The design part of the process requires some domain knowledge, so you need to know something about the problem that you're trying to solve, or somebody else with whom you are working needs to know about the problem you're trying to solve. Sometimes you will get to do an analysis of the problem, meet with the customer, study their needs. And when I say customer, of course, I mean it could be a traditional customer in the sense where they're paying you, or it could be another developer who has a need you're trying to fulfill. But we'll just use the term generically as customer, And I want that to imply that you should treat them like a customer. You want to keep their business, you want to make them happy, you want to meet their needs. Therefore, if you have a customer with a problem to solve, it'd be up to you to design classes that solve that problem, or, and in the cases of larger, more organized companies, you may have a systems analyst who does the problem analysis and some of the design work and then hands that off to you. And there's a hierarchy relationship of systems analysts to developers. At a formalized environment like a bank or an insurance company, typically those are different job titles. You may find yourself working with a systems analyst who graduated from the information systems program at a business college. A lot of those students want to be analysts. Or you may find yourself being put out there by your boss to meet with the customer and figure out exactly what the needs are and doing that design yourself. Now, we don't do a lot of design in this class. There is a systems and analysis design class in our program. If you stay and you finish your associate's degree, then move on to your bachelor's degree, you would take that systems analysis and design class. And I don't want to give the impression, it's important to me, that you don't think that we work in practice the way we work in this class. In practice, we don't sit down and start typing in class definitions, class templates, simply out of our head. We have much more context, much more analysis goes into that process. But since we're not doing design here, we very often are making up classes as we go along just to illustrate concepts. Do not fall into that bad habit when you go to work. Classes have data or properties, and they have behavior or methods. And that goes right back to the book title. Slide 3, Algorithms plus Data Structures. Our algorithms are implemented through methods, and our data structures are implemented through properties. The terminology is different, the meaning is the same. Now, if I ask you to model, for example, a person, you would ask me immediately what is the context in which that model will be used. You cannot create a good model unless you know the purpose of it. Is it a person who goes to school that you see, and we really only care about things relevant to college? Is it a person for the Social Security Administration, where we care about the date of birth and how much they've earned over their lifetime, if they're still alive, things like that? The purpose of that model is crucial to creating a useful model. Therefore, always look for context. Always think about what that model will be used for. Another thing to think about is, who is your audience? You're creating this class for someone to use. It may be you, it may be me, it may be somebody else at your business. It's probably going to go in a code repository. It's probably going to be used by many people. If you're writing good, reusable code, you're going to find that class is used throughout the projects that your company works on. And with experience, you will learn the functionality that should be provided when you create a class. You don't want to put in too much. You don't want to put in too little. And that just comes with experience. The phrase I use is adequate. When you create a class, do just enough for it to do its job. Don't go crazy. And that term, aim for adequate, comes right out of a book called Object-Oriented Modeling and Design, which again is not another programming language specific book. Rather, it talks about how to model things in objects. how the objects interact with each other, what notation you should use, why you should use object-oriented techniques. Another excellent book for getting you beyond just learning how to write a language, to give you a better feel for why we do what we do, and also make you more employable, because employers want more than just coders. They want people who can design things. Again, not a requirement in this class, just a recommendation for you. And it does sound silly, doesn't it, that we should aim for adequate. You're told your entire life, do the best you can, work hard, aim for the stars, exceed expectations. Yes, that's true in most cases, but when you're designing a class, you got to know when to stop. There is no perfect model. No matter how hard you work on something, you can come back the next day and think, oh, I should have added this or I should have tweaked that. That's why we shoot for adequate. We have to mentally condition ourselves to know when to stop. Again, all this comes with practice. Some general guidelines. You're going to create classes. You're going to put properties into those classes, and for the most part, all the properties should be private, and we'll talk about this in examples in a few minutes. And in general, all the methods should be public, but there may be some private methods as well. So if you're feeling your way along, you're not sure what to do, make your properties private, make your methods public, and then more of the nuance will come with experience. Another thing that we do almost universally is provide gateways or doorways, if you want, into the properties that we made private. Therefore, we create things called getters and setters, which are methods that are gatekeepers to those private properties. So at this point, I've talked enough. I'm going to stop on slide 13 for the moment. I will flip back over to Eclipse. Let's create a new project. As always, it's a Java project. It needs a name. And let's model an avocado. I've never had an avocado. I'm told they're good. So my project name will be avocado. And once I've got the project created, let's add two classes. We're changing our project architecture today. Things change. It's changing forever. No longer are we creating one class as we always have up to this point. We're now creating at least two classes and probably more. Let's add our main class first. The main class will have our entry point for the project, public static void main. I selected that. I called the package avocado lowercase a. There's my first class. In the same package, let's immediately add another class. And since we're modeling avocados, we will call this class avocado. Notice that it does not have a main. Remember, the main is the entry point for execution of the project, and there should not be more than one entry point at this time. A more complex project will have multiple entry points. That will introduce too much confusion for us. One main, one entry point, and that can be found in the main class. Now I have an avocado class, and I have a main class. Clean out this to do in the main method. The next thing you would do without hesitation is document by creating your document header at the top of each class. I'm not going to type in that entire header. You don't need to watch me type that. But I will put in a little placeholder just to remind you. Each module then should have that document header at the top. It should have that comment block defining all of the good things that we know should be there: name, email, assignment number, course term, year, description, citations, all that stuff. That goes in every module that you create. At this point, our project program doesn't do anything. The main is empty. And you have to pay particular attention now when you follow along with me, because I'll be switching back and forth between these two files. And when I type something in, make sure that you know where I put it. I'll be adding stuff to the main. I'll be adding stuff to the avocado class. Now remember, since we don't have a design and this isn't really a design class, we will make stuff up. And I am going to model an avocado The Java doc for the avocado class gives a very brief description of what the class models. My sentence is model an avocado on sale at Kroger. Okay, I have context now. It's not an avocado growing in a field. It's not an avocado in a bowl on your kitchen counter. It's not been made into guacamole. It's at Kroger waiting to be sold. It's in a big pile of its brothers and sisters. The next thing I would probably do is think about the data. Remember, a class has code and data, properties and methods, and the properties are simply variables that I declare which will describe an object of type avocado. And I'm going to say that an avocado has a color. Apparently that's very important to people who eat avocados. They want to know what color it is. And I decided that would be a string after zero consideration, because color is green and red and blue, and a word like that. I could also represent that as RGB, numeric values, or some other kind of color format. But since I am just doing this off the top of my head, I will make it a string. I'm sure you all agree with me that we could argue the data type of the color of the avocado for probably days and days. Some of us would want to represent it as a string. Some of us would want to represent it as an RGB numeric value. Some of us would want to represent it as its own class, not simply a string or a number, but an entirely separate class. There's all kinds of considerations to make. But again, this is not a design class. We're simply going to put it together just to illustrate concepts. The next thing an avocado might have is a weight. And I will make that an integer. And I will spell weight correctly. My variable is called weight in grams. The avocado has a weight. I don't know what it is. I think avocados can be weighed in grams. That feels reasonable to me. That's also private. Remember, our rule of thumb at this point is that properties are private. So we have two properties. The next thing we might do is add some behavior, which we implement by writing methods inside of this class. But before I do that, I'm going to go back to my slides again. And we left off with the concept of a getter and a setter. And that relates back to what we just did with those properties. What we need to do is build some kind of mechanism for other classes to be able to access that color and that weight inside of an avocado object. And I'm going to illustrate that through a little bit of code writing in the main. Make sure that you hit save periodically. I will go back over to my main class. The first thing I want to do is introduce you to declare and instantiate. Creating an object from a class is a two-step process. First, we declare a variable of that type, and then we instantiate an object and store a reference in that variable. On my screen, what I've done so far then is declare the variable. So I can put some comments in here. Declare a variable of type avocado. You've seen many variable declarations to this point. You've seen integers, strings, floats, array lists, booleans, doubles. Now you're seeing a declaration of an avocado object. We created our own data type. The next thing that you do is instantiate my avocado equals new avocado. This is instantiation. And we're saying that we want to set aside space in memory for an instance of the avocado class and store that reference to that instance in the variable myAvocado. Okay, so we're storing a reference to the object in myAvocado. And we'll be using the term reference quite a bit. At this point, you can think of a reference as a memory address. There's a lot more to it than that, but it does consist at least partially of a memory address. Now, the declaration and instantiation process can be done in one line of code, and I will do that later. Here we did it in 2 lines of code. We declared and we instantiated. Sometimes it's preferable to do it in 1 line of code. Sometimes it's preferable to do it in 2 separate lines of code. We'll make that clear as we go. If you flip back to the avocado class, a reminder then that we have 2 properties of an avocado. It has a color and it has a weight. And we want to be able to manipulate those from our main. We created an avocado instance, and what I'd like to do then is give that thing a color. MyAvocado dot color equals green. And I know I can initialize a string by using a double quoted literal. I know I can type quote green close quote and store that in a string variable. It didn't work though. I have an error under the word color, and it says the field avocado.color is not visible. Visibility is a reference to scope. If you flip back to the avocado class, you can see that the scope of the color is private, which means it's only visible inside the class. Let's add a note here. Private means the scope is limited to this class. Nobody else can see it. Unless you're inside this class, unless you have a method that is living inside avocado, the class, you can't reference the color. So we got a problem. And the problem is that program is not going to build. It will not run because there's an error trying to reference a private variable outside of the class. Now, the first solution that might come to your head is, well, I can fix that problem. Watch this. I'll go back over to the avocado class, and I will make this variable public. Now, the scope of that variable is the entire project for all intents and purposes right now. The scope got dramatically larger now. If I go back to the main, the error's gone. Poof. Everything's fine now. Syntactically, I'm good. However, logically, I'm wrong. Logic error. I broke my program. This is not the way we fix that scope problem. By making the scope of that variable public. That's not the way you fix it. That is a violation. Flipping back to the slides again. On slide 6, that is a violation of data hiding, which is an OOP feature that we don't want to violate. You can do it. It's just a very bad idea. And you may not as well be doing OOP if you're going to take those kind of shortcuts. Something that happens quite a bit when you're applying for a job is you find yourself in a two-step process. After you've applied, the first step is a phone interview where you talk to somebody. Usually it's a technical person, and they might ask you some questions just to see if you can put a sentence together and answer basic software engineering or programming questions. So that's a lot of times is the first step in that employment, in gaining employment. How about that? And a lot of times it's very popular for that person asking you those questions to ask you the definitions of these terms, because everybody should know them and everybody should have a definition right at hand, right off the top of your head. So that first phone interview that you get, you might hear a question like, what is data hiding? What is inheritance? What is polymorphism? And they may go beyond that and say, why are these good things and why are these bad things? Be very careful then as we go through this material to be sure that you can define these terms in your head, use them in a sentence, and explain why they are advantageous or possibly disadvantageous. Okay, back to our code. We agree then that making a class property public is a bad idea. I'm going to change that back to private. And that is going to cause the main to break again. The error came back. We can't have a reference to a private variable outside of the class code. But if I refer to the slides again, the way that we get around that, and I'm on slide 13, the way that we get around that is to write methods called getters and setters. That's a generic term. In C# they actually implement those names sometimes, but those are just generic terms in Java. We do end up creating methods using those words. So when I say you need a getter and a setter, you're going to write get color and set color. Let me show you how we do that. Remember that, and I'm still in the avocado class here. Remember that I do have access to this private variable as long as the code is in the avocado class. That means I can write a method called get color, and that's an arbitrary name. That's not special or reserved. We just make it up that way. And then that method simply does a return statement on color. Whoops, and I didn't finish the method signature, did I? Got excited there. Public string get color. So there's a method that lets other users of my class access the private variable that stores the color. If I go back to the main again, all I have to do is change this line of code in line 10 to use the getter or the setter as necessary. And let me finish the thought before I come back and fix the main. I wrote a getter. Let's write the setter. And that's going to be public void set color. And this little guy is going to take a parameter. This is the method that you call to store a value in that private property, which will look like this. This dot color equals color. This looks very weird, and we'll spend some time talking about it because it's important to understand. Now I have a getter and a setter for the color property of the avocado class. And if you refer back to the slide again, we talk about combinations of get and set methods. And I may tap you on the shoulder at work and say, I need a getter and a setter for property X. I need a getter and a setter for the color of this object. And you might say, oh, I forgot to write those. I will make those available to you immediately. The answer then is not to make the class variable public. It is to write the getter and the setter to provide gatekeepers to access that private variable. Now we do need to document these methods. So let's go right above this, the getter, and open a Java doc. And Eclipse builds the Java doc framework. We can write a one-sentence description. I wrote get the color of the avocado as the description in the Java doc. And then Eclipse also provided that return annotation, which tells the Java doc processor what kind of information is going to be returned from that method, and you can just put return the color. It looks a little redundant because we're doing some very simple property manipulation, but it works. Then we do the same getter and the same, Java doc philosophy for the setter. I'm going to go store a value in the color of the avocado. The parameter, what is being passed to that method, would be the new color of the avocado. Now we've Java docked. We've created Java doc notation for both of those methods. We have a getter and a setter to access the private property color of the avocado class. You will do this over and over and over and over and over. In some situations, it will be done for you by the design tool. The design tool will have specified that an avocado has a color, and a preprocessor of some kind will take that design tool and spit out the getter and the setter, and actually the class itself even. So a lot of the code gets written for you, and it saves you a lot of just busy work. But we don't have that tool here. All right, we still have a problem in the main. We still have a problem because we're trying to access the private variable color. It is out of scope. You can't do it. It's not visible. But all we have to do is change this to set color and call it like a method because it is a method. Now we're good to go. We're going to say invoke the setter, to define the color. That works. The error goes away. We now have a gatekeeper method called setColor, and it does the work for us. The question that comes up quite frequently is, why do we do all this stuff? This was a lot of work. Instead of just making this public and solving the problem within seconds, we insisted on that color being private, and that caused us to have to write another method and then another method. So every time we create a private property, we're looking at probably creating two methods, a getter and a setter. And that's more work, but why do we do it? The reason we do it is data hiding. The reason we do it is because as the designer of the avocado class, I know more about avocados than you do. And I know how to store the color and process the color and retrieve the color, but I'm not going to give you the freedom to do that. You have to go through my getter and setter to use my data. And let's do an example of that. Let me restate the problem. We are concerned as to the amount of work we have created for ourselves, because every time I add a private property to a class, I find myself having to write at least two methods, one getter and one setter, to access that private property. Whereas it seems like it would be just a lot more convenient to simply make that property public. And we mentioned that making it public violates data hiding rules, but we really haven't talked about what that means and why it's important. Let's say, for example, then, that in my main, I'm calling set color, and I don't know what the color of this avocado is, and I'm just going to make it blank. All right. I didn't write the avocado class. I'm on the other side of the world. I'm tired, and I'm not putting any thought into this. But I would like to use the class because it seems important to me and useful. And instead of actually giving it a color, I'm just going to pass a blank string. Well, that works. That works fine. Logically, it's wrong. Syntactically, it's correct, because when I end up in the setter, it is simply going to store a blank string in the color of the avocado. The designer of the avocado class, however, is now deeply offended, because it would make no sense for an avocado sitting on the shelf at Kroger to not have a color. We need to keep track of these colors because it tells us when they're going bad or when they taste the best or something. I don't know. But as written, the program, the class avocado, lets you store a blank color. And there's two things I can do here. One is I can go over to the avocado class and I can put in a big comment. I'll just put it right here because I'm not sure really where to put it. The color cannot be blank. Okay? And I'm happy with that because it's screaming capital letters, but it's very unlikely that the other developers are going to take the time to study my class, and it's even more unlikely that they're going to respect what that comment says. That's just an advisory piece of information. They can ignore it, and they will. So we don't want to do that. That doesn't accomplish anything useful. What I can do, however, is in the set color, I can make sure that the color meets my requirements. And I know at this point one requirement is that I don't want it to be blank. So I can say if color dot equals empty string, and watch this, I'm going to be really devious. Throw new exception. If I can spell exception. Avocado colon color cannot be blank. Now I've made it perfectly clear and impossible to ignore that if you call my method with a blank color and try to set the color to empty or blank, I'm going to yell at you and I'm going to break your program. I don't care if you read my comments or not, you have no choice but to honor that. Notice also I'm refusing to store the new color because the throw new exception takes me right out of that method. I never get to line 30 where I store the new color, that blank color that you tried to foist off on me. So this is a way to do validation on the avocado side. It cannot be evaded. There's no way around it. If you're going to use my class, you have to follow my rules. You have to call my setter, and you have to pass me something that I like, or otherwise I'll throw a fit and I won't store it. That's the reason why we do what we do. That's the reason why we honor data hiding. That's the reason why we don't make everything public and then just walk away. So we've encapsulated data and code, data and behavior into this nice little class. And then tomorrow, if another project in the company requires an avocado class, they could conceivably grab this class out of one project and install it into another project and be off to the races. I've written reusable code. I should be very proud of myself. Well, in theory we're good. In practice we're still bad. By adding this throw statement to the set color method, I broke the method because you can't throw an exception unless you advertise that you're doing so. If you hover over that throw, you can see there's an error and it says unhandled exception, meaning that I've either got to tell the world I'm throwing it or I've got to handle it internally there, handle it on my own. Well, what I want to do is add a throw declaration. That's what I want to do. So I take that fix that Eclipse offers and it adds two things. It adds the throws exception clause to the method signature, and it adds a throws exception comment to the Java doc. This tells Eclipse and Java and the entire world that this method might just throw an exception if it feels like it. Doesn't mean it will every time, but it could happen. And I'm going to annotate this throws exception if color is blank. Now the whole world knows don't pass me a blank color or I'm going to have a hissy. Make sure you hit save. Go back to the main. Still not right. You still have another error. Things just keep getting worse, don't they? Every time we improve our program, we break it. Now I have a problem in the main because I'm not handling the exception that might be thrown by setColor. And I have two choices here. I can surround that call to setColor with a try-catch, or I can just say, I'll let the rest of the world handle it, let Java handle it. I can add a throws declaration to the main, and that's what I'm going to do because it's just painless. And this tells Eclipse and tells Java that this main method may throw an exception, which doesn't really do anything because Java would catch that exception anyway, even if that wasn't there. That makes the error go away. Okay. Oops, I spelled color wrong. Now, I'm still going to get the exception because I did pass in a blank string. I want to run this and I want to see that exception. Here we go. Everything is saved. All the errors are gone. Get ready. Where's my console window? There he is. There's my console. Look at the exception in the console window. There's the message from my exception. It says avocado : color cannot be blank right in the console window as generated by the exception that I threw. Everything works now. I've demonstrated data hiding. I've demonstrated how to do validation in a getter method. Watch what else I can do. If I hover over set color, there's the Java doc from the set color method. That is very powerful. If you write a good Java doc, you make life easier for all the developers who use your class. Because I don't have to go back and look at the source code for the class now. I can just look at the Java doc. It tells me everything I need to know. We're learning how to write robust, object-oriented code. The next thing I want to do is clean up a big loose end in the avocado class. There's nothing wrong with it. We just need to do some clarification. Take a peek at the set color method. And in line 31, there's some very odd looking code. We have this dot color equals color. That doesn't make a lot of sense on the surface, so let's talk about it. Look at the signature of the method. Look at line 27. And line 27 is a variable declaration in the form of a parameter. We're saying that this method is going to receive a string from whoever calls it, and we will refer to that string as color. So we have a string called color. However, there already was a string called color, and that's up here in line 10. We have two things called color, and they're different. One is a class level variable in line 10. One is a method level variable in the form of a parameter in line 27. So I need to be able to refer to those two things. And if I just say color, the reference is line 27. Look what happens to Eclipse. If I click on color in line 31, it highlights color in line 27. It shows me what that refers to. So I can see that just by writing color, I get a reference to that method parameter. If I click on this dot color, look at line 10. It highlights line 10, indicating that by writing this dot color, I am referring to the class level variable. So I can have two things with the same name, and I can refer to them uniquely simply by using the this pointer. That's what we call it. We call it the this pointer. And this is elegant, correctly written code. It just looks weird. Now some of you might be thinking, and I hope you are, why don't I just change the name of one of those two variables and then I don't have this problem anymore? And let me show you what I'm talking about. What if I write color equals color? Now we know that's wrong because both of those things refer to the same variable, and it doesn't make any sense to say x equal x or color equal color. It doesn't accomplish anything. Eclipse even realizes that and puts up a warning. It says the assignment to variable color has no effect, and the meaning is because it doesn't make any sense to assign a variable to itself. It accomplishes nothing. So you get to thinking, all right, how do I make that warning go away? Okay, why don't I just change the name of the parameter? How about color x? And then down here I can say color x. That made the error or the warning go away. Line 32 is now fat, dumb, and happy because they don't have the same name anymore. Color x is a unique name that refers to the method parameter, and color without the x is a unique name that refers to the class level variable. That works too, but it's awkward because now you find yourself creating new names for the same thing. They are both a color, and there's no reason to name them differently. So what we prefer that you do is use the this pointer to differentiate between the method level variable and the class level variable. And I'll just put, we can do this. This works if we rename the method parameter, but it's awkward. And you're going to see people do it, okay? There's nothing inherently wrong with it. It's just not the best way to solve that problem. And I think it doesn't like my spelling of parameter. Hopefully that is a little clarification on the this pointer. When you tack this onto something, this refers to the current object that invoked this method. And that's how we look at it. All right, we've created a getter and a setter. We've done a little bit of input validation in the setter. And we've discussed how the this pointer works. We stopped on slide 13. This is slide 14, reiterating the philosophy of data hiding. When you create a property or a variable inside of a class, it should be private. And then you write getters and setters to allow other users who will use your class to access that private variable. So we've spent a good amount of time talking about the concept of data hiding. You should be able to explain why it's important, and you should be able to implement the concept using a getter and a setter. Remember that whenever you create a class variable, you're looking at two more methods, a getter and a setter, almost all the time. There'll be some rare occasions where you don't need to write a getter and a setter, you just need the variable. But for the most part, create a variable, automatically train your brain to think about writing a getter and a setter. And then in this particular setter, we decided to do some input validation on the parameter. We decided that if we were given a blank color, we would refuse to store that color and we would throw an exception. And that's a subjective decision. We decided that's the best way to handle this situation. Sometimes you'll just ignore the information and not store it. In this case, we decided to be mean and throw an exception to tell the world that there was a problem. In the next video, we'll pick up where we left off in the slideshow and continue building on this example. Thank you.